setting up analog sensors. I have two of them here. This one's my potentiometer, it's my dial, and this one's my photoresistor. That one senses light. So they're going to be set up a little bit differently, each one. So right now I have on my breadboard, I have power and ground set up to my breadboard, and I've plugged in my potentiometer, ground here, power here, and in the middle I have attached it to my analog side of my board. Pretty straightforward. You'll see I don't have a resistor. The reason for that is it has a resistor in it already. We don't have to worry about that. The photoresistor, it's a little bit more simple of a device, so we have to put our resistor into it. One side I have power. The other side I plug in to my analog, and then I have a 10K resistor that is grounded out. So this is how you would set up either one of these. If you have an analog sensor that has a built-in resistor, doesn't need one, it will be set up something like this. And if you have an analog sensor that needs a resistor, it will be set up something like this. I have also included some code here. Very simple code. All I have is a serial begin and a serial print. When we have analog sensors, we have to, the main thing is there's only two big differences between what we have going on here and what we have when we are using a button. So the first thing is I should probably do a better job of coming up with a variable. I'm going to call this my pin. That's going to equal 0 for now. I don't have to set it up. It's already set up. This is an analog in. I don't have to pick whether it's input or output. It's automatically an input. And here, I was just doing some tests earlier. I'm going to simplify this a little bit. I want to break it apart so you can see the different pieces. Before we do a Boolean, because there was either it's pressed or it's not, in this case, the numbers that I can have are going to be between 0 and 1023. So I need a data type that can hold that. And an integer will do just fine with that. I'm going to call it value. And if I want, I can declare space and a name and initialize it all at the same time. So right now what I'm going to do is, here's one of the differences. Number one, integer instead of Boolean. And the next thing is, it's just going to be instead of digital read, it's going to be analog read. And then I'm going to print my value. Now it's going to go really quick because I don't have a delay in here. I'm going to start my simulation. And right now, it's starting at 54. In our case, because of this resistor, we're looking at this pin here. So we're looking at our photoresistor. This is starting at a, let me see, why are you there? Move. There we go. I want, stop the simulation, start again. I don't want that photoresistor there. Normally it allows me to slide something. All right, let me change to the other one for now. We'll do pin 5. And you know, sometimes things just don't work out well, so we'll see how this works. So we'll see with this one, we can see the slide happening. 1023 is my max. I can be things in between, that's what makes it analog, all the way down to 0. Stop the simulation. I'm going to change this back to pin 0, and we'll see if I can get it moving. See, that one's not changing. So I changed to pin 0, and it doesn't like this right now. All right, there we go. All right, so now I can slide this back and forth. And because the photoresistor is a little bit harder to control, you're not necessarily usually going to get from 0 to 1023. Those are just possible values. You might be somewhere in between. So now what do you do with this? An if statement, just like anything else. Don't think of this as anything brand new. I can just say if value is equal to 0, just like I would with a button. I could also give it a range if it's less than this or greater than this. So that is our crash course in analog.